Welcome back, and today's clown is Level Earth Observer, the alleged crane driver with the clear Pantodane fetish. He is the typical reality-denying flat earther and clearly is not the sharpest tool in the box. Like all flat earthers, he keeps trying to convince the world of his flatardia fantasy world and posts videos that end up debunking his point of or proving the globe. Just like his video channel header. There's curvature in that bridge, Leo. Like always, he cherry picks and misrepresents the facts. Today, Leo, our low educational outcome, is looking at the SR71 Blackbird.
Gonna have another look at my favourite plane of all time, the SR71. In case you don't know, the SR71 is a long-range, high-altitude Mach 3 plus strategic reconnaissance aircraft. It's now retired, but was the baddest aircraft on Earth. Fastest, holds all the records, and even now just looks futuristic and looks the business. Just love this plane.
That's right, folks, you heard it here first. Leo loves this plane. But, Leo, you're a NASA denier. You claim NASA fakes everything. And as NASA operated this aeroplane along with the US Air Force, did this aeroplane actually exist? Was it really real? Was it just a fake? Was it one of your Airfix kits? Oh, will we ever know? But do carry on, Leo. Let's have a continual laugh.
What we're interested in is its top speed, performance, maximum speed, 2,200 miles an hour, okay? So we've got that as a reference. Bear with me. So the Blackbird going full speed for an hour, 2,200 miles an hour, it will travel 2,200 miles. So I'm going to put that in the Earth curve calculator. I want to see what the fastest plane on Earth has to deal with when it's going full speed, i.e. the amount of supposed curve drop it's going to encounter, or it did encounter. I put in an eye height of 0. I'm only tracing the ground, simulating what the SR71 is supposedly doing in the sky. Actually helping the globe believers out here by using a smaller radius, i.e. the ground, rather than 80,000 feet up in the air. So when we calculate, we put in the speed, top speed for the SR71, 2,200 miles. Eye height, I don't need to do that, as I said, the plane is following the contours of globe Earth supposedly. And I get a figure of 3,010,798 feet. That essentially translates to 570 miles of curve or drop. So at this, basically the SR71, over the course of an hour going full speed, it can only go full speed up to 1.3 hours because of fuel consumption. But the SR71 going full speed at 2,200 miles an hour for an hour would essentially have to drop 570 miles to remain level on a ball. Think about that.
Are you serious?
Oh dear, Leo. You don't seem to understand how aircraft really fly, do you? And, more to the point, you seem to be missing some of that Earth curve calculator you dragged up off the internet. You seem to be missing the diagram that explains the measurements that you are claiming. Does that mean you don't understand the simple diagram? Is it far too complicated for you? Or will it just give the game away? As you have put eye level at 0 feet, therefore the horizon is just a tiny fraction in front of your own eyes, you seem to think that the SR71 will fly straight out parallel to your line of sight until it gets about 2,200 miles away and then suddenly drop 570 miles downwards. You even debunk this yourself by saying it follows the contours of the planet. This Earth curve calculator is not hard to understand, unless you're a flat earther, of course. Your eye height, which is HO in the calculating field there, is at the horizon, and the line of sight will be a tangent line. The target, in this case the SR71, is 2,200 miles away and on the ground. The drop height H1 is the difference between your line of sight tangent line and the SR71 target on the ground. If you could see through the planet, you would only have to lower your gaze by 15 degrees in order to see the target of the SR71. The SR71 has not dropped by 570 miles. It's just your line of sight has to drop 570 miles, or just a little under 16 degrees. Let's try and make it simple. I have drawn to scale Leo's illustration. At point A, Leo has his eyes at ground level, so the horizon is literally at that point in front of his eyes. And his line of sight is shown, and that forms a tangent line 90 degrees to his eyes. I have now drawn a SR71 at point A. It is at 80,000 feet. And now we fly that SR71 at a constant altitude of 80,000 feet to point B, where it still is at 80,000 feet and it has flown a flat and level flight. The drop from Leo's line of sight to the SR71 at 80,000 feet above point B is on this diagram almost a centimetre in length, which translates to, in this scale, to 917.326 kilometres or 570 miles. And that is just the difference between Leo's eyesight line to the new position of the aircraft. The aircraft hasn't dropped 570 miles. Just Leo's eye line has to drop that equivalent distance at that 2,200 miles distance. But Leo seems to think that the SR71 flies this sort of flight pattern. Goes out 2,200 miles, then has to drop 570 miles, then fly another 2,200, and so on and so forth. How an air-breathing engine can fly so many thousands of miles into the vacuum of space, who only knows? But hey ho, we shall see. Leo carries on with this stupid idea and we can have a laugh.
So this incredible plane would have to drop 570 miles an hour to remain level on a ball when it was going full speed. Just have a quick look at this diagram. Point A being the start, minute 1, point B being the 60th minute between the 2 points of reference. According to the globe, that plane, the difference between the 2 points of reference is the plane at point B is 570 miles lower than point A. So that's just mind-boggling that that plane has to change that much in elevation over 60 minutes. Now I'm just going to break it down to get some idea of averages here. Now if I was to break down the 570 miles an hour and divide that by 60 minutes, this is just as an average to get some idea of the silly numbers involved with this globe fantasy, okay? Now if I was to divide the 570 miles by 60 minutes, I get a figure of 9.5 miles per minute supposed drop. It's ridiculous. Now if I was to break it down even more and divide that 9.5 miles per minute by 60 seconds, I get a figure of 836 feet per second.
Every word of what you just said was wrong.
The SR71, like all aircraft, obey the same flight principles. These principles are built up around the four forces acting on a body in flight. They are thrust and drag, and lift and weight, where weight is the mass of the body times acceleration of gravity, which is 9.8 meters per second squared. Knowing gravity is extremely important, particularly in aircraft that are going to perform aerobatics or intense maneuvers, so that the increase in weight can be calculated and the aircraft can be built strong enough to withstand the increase in weight due to the increase in all these aerodynamic forces. For successful flight, lift has to balance weight and thrust balances drag. If you increase thrust, the plane will go faster. If you increase the drag, the plane will get slower. If you increase lift or decrease the weight, the plane will rise. And vice versa. Lift is dependent on how fast the aircraft is moving forward through the airflow. Flight control surfaces, ailerons, rudder and elevators cause the aircraft to turn, climb and roll. All aircraft have altimeters to determine height above mean sea level. Altimeters again debunk another flat earth fallacy of no pressure gradient in the atmosphere. Altimeters work on there being a pressure gradient. Simple altimeter works by having air in a sealed bellows inside the instrument case. The case is open to outside atmosphere via pipes and a static port in the fuselage. As the aircraft climbs, the pressure in the case decreases. The bellows expands. The bellows are connected to a geared linkage that drive a pointer on a calibrated scale on the front of the instrument face. As the bellows expand, the pointer is driven and it indicates an increase in altitude. As the aircraft descends, the pressure in the case now increases and causes the bellows to contract, driving the pointer in the opposite direction and thus displaying a decrease in altitude. Aircraft use this simple instrument to fly at a constant altitude above and parallel to mean sea level around the globe. Radio altimeters are used to give a highly accurate altitude indication up to a maximum of 2,500 feet above terrain, and are used in aircraft systems such as the Autoland system and the ground proximity warning system to avoid terrain below the aircraft. With increasing altitude, the air pressure decreases due to the fact there's less of it the higher you go up. Temperature, on the other hand, doesn't follow quite such a route. It does decrease as we gain altitude, and then through a region called the tropopause, which is towards the top of the troposphere and below the stratosphere, the air temperature stabilizes to around about minus 65 degrees centigrade for several thousand feet. Then the temperature starts increasing to the point where we get to the stratopause, which is between the mesosphere and the stratosphere, again several thousand feet deep, where the temperature stabilizes again, and then we see the temperature go the other way and start decreasing, as in the diagram illustrated. Commercial jets fly above most of the weather on the planet in the tropopause region. In order to do this, and for you to have a comfortable flight, the aircraft needs to be pressurized, and the cabin altitude is pressurized to an equivalent of about 8,000 feet. And with the advent of stronger, lighter materials such as carbon fiber, the aircraft cabin altitude can be reduced to 6,000 feet, as in the case of the new 787, and this makes the flying experience even more comfortable. This is why you can fly dressed like this, and not like the crews of World War II high-flying bombers. But I digress, Leo. Let's hear some facts about the SR71 you don't want to talk about. Let's hear what 3 retired SR71 pilots have to say about their flat earth crushing aircraft. First we'll hear from Lieutenant Colonel Jack Veff, then we'll hear a few words from Colonel Joe Kinigo, and finally Colonel Buzz Carpenter has a few final words to knock into that coffin of flat earth.
The aircraft flies at Mach 3, as I mentioned. So what is Mach 3? Well, it varies with temperature, therefore it varies with altitude as far as the Mach number goes, but Mach 1 would be approximately 1,000 feet per second. You could extrapolate that out, and Mach 3.2 would be about 32 to 33 miles per minute. So if you were here, or let's say you wanted to fly from Orange County to Los Angeles, it's about 60 miles, you could do that in 2 minutes in the SR71. Now, you're not going to do it from a standing stop. You've got to be at speed and altitude before you get there. It flies between 14 and 16 miles in the air, and from that altitude you can see the curvature of the Earth, which is fascinating to see, and I do have a picture of that I'll show you. The aircraft flies faster than the rotation of the Earth. So what that means is if you're heading west at around sunset, you can head into the sunset after it's set, and the sun will rise in the west. I promised you a picture of what the Earth looks like from 80,000 feet, and you can see the curvature of the Earth in this picture.
The SR71 was the final design of the Blackbird family of aircraft. It could travel at speeds of Mach 3.2, although Mach 3.3 could be reached if necessary. Its maximum altitude was 85,000 feet.
At those altitudes, you can see the curvature of the Earth, about 350 miles. At those speeds, you fly faster than the Earth rotates, so it was not uncommon for me at night to fly in a westerly direction and actually see a sunrise come up in the west. During the day, the sky is a deep, deep blue, not quite black. You can see the different shades of blue as you're looking down into the black. You can see some of the brighter stars during the day, and my guess is what you're seeing are probably the planets, Venus and Mars and all. At night, you cannot see constellations like we see them here, you know, Orion and Pegasus and those things. You can't see those, the Big Dipper, because at night, the entire sky is up that altitude is just one big Milky Way. I mean, it's nothing but stars. It's just the most beautiful sight you've ever seen in your life. It's absolutely incredible. I was flying a mission over the North Pole once, and because of the way the Earth is shaped and longitude and latitudes up there, got over the North Pole. I had about an 18-minute transit to go all the way across the pole, and in 18 minutes, I had a full moon rise over my right shoulder in the cockpit and set to the left 3 complete times. The moon just went around the cockpit like that 3 complete times. It was absolutely the most amazing thing I had ever seen.
The SR71 is a combination of power and majesty. When you look at it, it just has a mystique that I think is going to live for generations and generations. I wish I could take everybody up to 85,000 feet, because you can see 350 miles in any direction. You can see the curvature of the Earth. Mountains, 10,000-foot mountains look flat.
Hey Leo, it looks like this SR71, your favourite aeroplane, is killing your fantasy world of Flatardia today. But Leo still has more nonsense to spew. Let's have a listen.
Today is all about aeroplanes and observations. First up, we're going to revisit Jay Toland's cracking observation of Baja from Texas. And then we're going to get really high and absolutely annihilate the globe off the back of JT, and of course using the globe mathematics with a little bit of help from the United States Air Force. So let's have a look. First up, of course, is JT's 760-mile observation of Baja from Texas.
Dearie, dearie me, Leo. You are stupid and gullible, aren't you? Well, let's hear exactly what you can see at 80,000 feet from a SR-71 pilot. Go ahead, Colonel Buzz Carpenter.
I wish I could take everybody up to 85,000 feet because you can see 350 miles in any direction.
Take it away, JT. Incredible, considering the globe mathematics tells us that Baja, what we're seeing there, should be 35 miles behind globe Earth curve. 35 miles.
It would be amazing if that was actually what we were seeing, but it's not. All we have is a flurf with a digital camera and a filter thinking they have achieved something not even the US Air Force has achieved with the state-of-the-art photographic equipment they had fitted to the SR-71 and the U-2. Buzz Carpenter, let's hear it again. How far can you see at 85,000 feet?
I wish I could take everybody up to 85,000 feet because you can see 350 miles in any direction.
So at 85,000 feet you can only see 350 miles. Well, a commercial passenger plane that's cruising at 35,000 feet is not going to see that. You're likely to be only to see at best around about 250 miles in all directions from that plane. Using the heading information and the position coordinates kindly supplied by Leo's flurf friend here, and the position of the jet engine, we can see Jay Toland has a field of view as indicated approximately. We can see there is no noticeable features in the terrain until the mountains in the distance, and then a long ridge line beyond those mountains, which he claims to be Baja. Well, one look at a map instantly disproves his claims of that land being Baja. Let's have a look at this map. As we can see on this map, we have a large area of flattish terrain with mountains beyond, and then just beyond that mountain range, after a narrow band of, again, flattish looking ground, we have a long ridge line with a similar appearance to Baja.
Here's Baja on Google Earth, and here's a side-by-side comparison. Incredible observation. 760 miles from an altitude, I think, of 34,500 feet, I believe it was. Incredible.
You can't be serious, man. You cannot be serious!
Leo, wow, how dishonest of you, comparing a picture from 35,000 feet with an image at hundreds of miles high. Well, using Google Earth as you did, here is a comparison from 45,000 feet. Notice the difference? It's not a mystery to me, or should it be to you? That's right, no sign of Baja. Well, not until we get above the thunder in the mountains and to about a height of about 200 miles.
Our next observation by an American hero, a United States Air Force Major, Brian Shaw, who was a SR71 pilot. His observation, believe it or not, was of 1,400 miles, possibly further. But let's have a quick listen to Brian, and then then we'll have a look at the globe maths and see how ridiculous this globe nonsense really is.
Now Leo deliberately misunderstands what is actually said and twists the words of an American pilot. A light-hearted story told by Major Brian Shaw, retired SR71 pilot, at the end of his motivational lectures, which was originally inspired by a 12-year-old boy's question at one of these lectures, is taken out of context by Leo. I have listened to Major Brian Shaw's whole lecture, and the various versions are well worth listening to and taking time to check them out. I will leave a link to Brian Shaw's lectures below in the comment section.
Walter and I were doing a training mission around the United States where you just were building up hours and time, and we take off out of Beale, hit a tanker in Idaho, rip on up to Montana, zip across Denver, hang a right turn in Albuquerque, out over Los Angeles, up to Seattle, back into Sacramento, 2 hours, 21 minutes. And you just do that then you do it backwards, and you hit a tanker or two. It was just to gain crew coordination, build your hours. We're on our last training mission. We're over Tucson. I can see downtown LA from Tucson. We're at 89,000 feet. I can see the whole western United States bathed in a warm October fall glow. I can see the chain of Rocky Mountains from Canada to New Mexico. I could just see the most beautiful picture laid at my feet.
I bet you can, Brian. And if you could see the chain of the Rocky Mountains coming from Canada all the way down to New Mexico, I'd say you could see a bit too far for the old globe model, me old mate.
There's not much between the ears.
Classic flurfer misrepresentation of what was actually said. Major Brian Shaw is only stating a geographical fact. The US Rockies do stretch from Canada to New Mexico, and the US Rockies are part of the Canadian Rockies. Leo, if someone told you to go down to Land's End and look out at the North Atlantic Ocean stretching from Iceland to Brazil, are you going to be dumb enough to expect to see either country now? They have only stated a geographical fact, just like Major Brian Shaw did in his lecture.
If we were to put your observation height and what you were seeing into the globe calculator, it turns out the Canadian Rocky Mountains that you were seeing at 1,400 miles away, Brian.
Leo, Major Brian Shaw never said he saw the Canadian Rockies. He said he saw the chain of Rocky Mountains from Canada to New Mexico. Leo, you are just trying to manipulate what was said, so it fits your fantasy of Flatardia world. Leo, like all flat earthers, just cherry picks what he wants to hear, that he believes validates his fantasy world of Flatardia. Leo is far too lazy to actually research, and in this case clearly has failed to comprehend the context of the remarks made by Major Brian Shaw. If Leo had bothered to listen to the whole talk by Brian Shaw, he would have understood the context of the story. Here we are, Leo. Here's something for your little tiny brain cell to get confused about. Here's an extract of that same little chat by Major Brian Shaw at a different conference. Go ahead, Brian. Take it away.
One day, Walter and I are doing a training mission around the United States. We take off out of Sacramento, hit a tanker in Idaho, accelerate up to Montana, hit the high Mach over Denver, hang a right in Santa Fe, out over Los Angeles, up to Seattle, back into Sacramento, 2 hours, 20 minutes. And then you do it backwards just to gain time and experience. It's just training, just a couple of refuelings in there. We made the turn at Santa Fe, and we're over Tucson. And I can see downtown LA from Tucson. And it is a beautiful late in the afternoon, 6 o'clock October fall day. The whole western United States is bathed in a warm glow of just an October afternoon. Silence on the radio, smooth as glass, not a gauge moving in my cockpit. We're blowing cactus down 18 miles high. And I'm thinking, we bad. I'm looking in the mirror, oh yeah. And I feel sorry for Walter. He's got to monitor 5 radios in the back seat.
Leo, you clearly have no comprehension of the true speed of the SR71. The SR71 would be doing just over 100 miles every 3 minutes. So that would mean, as it passed over Tucson, within just over half an hour, it would be 1,200 miles away at Seattle. Like all flat earthers, Leo thinks he has proved flatardia, but as always, with absolutely no physical proof or evidence, other than the tiresome "duh, it looks flat to me" remarks. In reality, like all flat earthers, Leo only proves his stupidity and ignorance of the world we live in. I think that's enough stupid for one day. I hope you enjoyed the video. Thanks for watching. Take care.